Today we are going to cover Pandas useful techniques. This is going to be an hands-on exercise, so get your Jupyter notebook ready and start coding as you can see in the video. First of all, we import all the libraries. For data analysis, we have Pandas. For scientific computing, we have NumPy. For data visualization, we'll be using Matplotlib and Seaborn. ML library for classical ML algorithms is scikit-learn. For mathematical function, we use math. So after importing, if you want to check the version of the pandas that you're using, then you can do so by pt.version command. If you want to create a series, then you can create a list, and then this list will act as the index, and this command will create a series of random numbers, so you can see this as the result. If you want to check if b is in S or not, so it will give a boolean value, true or false. Get the value of index b, so S of b gives you the value of b, so you can check this is the value of b. List the indexes in the series, so S dot index will give you the overall indexes which are there in your series. If you want to map your series to a dictionary, you can do so by toDict function. So mapping is equal to s dot toDict function, and then you can see by printing mapping, you can see that this has been converted into a dictionary. Convert dictionary to series back, so s equals to series of mapping. So you can see this is again in the form of series now. Access values by slicing s until index 3, so this will give you the first three values, so 0 1 2. Convert series to string, so you can do so by using the function toString. Get the index of the series, like I said before, use the function index s dot index, so it will give you all the indexes in the series. Map new indexes to a series, so if you want to add a few more indexes to your series, so you can do so by giving the index name here, like I'm adding G and H as a new index, so G and H, and you can see a series here, and this is basically the value of this index is NaN, which is null. Check for null values, so you can do so by using the function is null, so this will give you the values at index as G and H. Check for not null values, just use the function not null, so this will give you the three values A, B, C which are not null. Drop the values where at least one element is missing. You can do so by using the drop NA function, so you can see the result as A, B, C, the three values where the elements are not missing, and it is not showing G and H because these are the missing values. If you want to do any arithmetic operation to a series, you can do so by using the arithmetic operator star, plus, minus, or division. So s star 2, and then you can see that this has been multiplied by 2. S plus 2, so it will be addition plus 2. Now coming to data frame. Data frame is basically a 2D collection of series. So if you want to build a data frame, df is equals to data frame, and here you can give the index and the values. So for A, I'm generating six random values. For B, it will be high and by six times, and C the same. I'm generating random values. So if you run, if you want to print df, then it will show you this value. So you can see A has got these random values, B has high and by this, and C is again the random values. So A, B, C are the columns. If you want to list the columns of the data frame. So you can do so by df.columns. It will show you A, B, C as your column here. List rows of the data frame. So df.indexes, and it will show you there are overall 6 rows. So you can see 1, 2, 3, 4, 5, 6. List values in a column A. So you can do so by df and giving the column name A, and this will show you all the 6 values belonging to the column A. Add another column to the existing data frame. So let's say you have 3 columns A, B, C here, and you want to add D. So you can do so by initializing it. Df D is equals to what's up stars into 6. So this will give you, and if you print the data frame, this will give you the column with the values what's up. List values after slicing indexes. So you can do so by using df for first 3 columns, for first 3 rows, sorry. So it will show you 0, 1, 2, 3. List values based on label based indexing. You can do so by using LOC. So you give the slicing here and the columns. So for B and C column, it will print the values from row 2 to 5. List values based on position based indexing. So you can do so by using iloc and specifying the indexes. So it will show you the value from 2, 3, 4. List values based on some conditions. So you can do so by giving some condition here, like I have given for all the records where the value is greater than 0 in the column C. Create a new data frame with index as date. You can do so by initializing index is equals to pd.daterange, and you can give the date here. So you can see this is my index here. Add more columns to the data frame. Let's say if you want, you just have 3 columns right here, A, B, C, and if you want to add D, then you can do so by just giving the column name D here, and by default it will take NaN values. Check if the values are null or not. So you can do so by using isNull command, rather function. So this will show you, yeah, for D column all the values are null, so it will show you true. If you want to create a data frame using nested dictionary, you can do so. You just first of all create a dictionary. You can see I've created a dictionary here, then I've converted into a data frame using this function data frame, and then data, which is data is basically my dictionary. So you can see this in the form of data frame now. And if you want to delete values based on some column on the rows, let's say I want to delete values for hey column and C row, so this will delete this value. So you can see after running this I get the values as NaN here. Now coming to the data analysis part, you have your CSV somewhere on a computer. For me it is on the desktop, so I'm going to read the CSV. So pd.read CSV. Then after reading the CSV, I want to show all the data which is there in the CSV using this stocks data. If I want to show top 5 records in the stocks data, then I can do so by using head function. It will show you first top 5 records. If you want to show the last 5 records, then you can do so by tail function. So you can see these are the last 5 records. If you want to show unique values in a column, let's say in the name column, what are the unique names, let's say AL, APL, which is apple. So you can do so by using the unique function. It will list down all the unique names there. If you want to show statistics like mean, standard deviation, count, percentile, maximum, minimum, then you can do so by describe function. So you can see all the values for each and every column which is there in your CSV. If you want to show column information like count, type, null or not null, memory usage, etc., you can use info function. It will show you all the details here. Show number of records in each column. You can get the records using the count function. So you can see there are almost 6 lakh 19,029 records in the column open, and likewise in the high, low, close volume name column. If you want to list values based on position based indexing, then you can do so by using iloc and specifying the range here. So it will show you 1 to 20 records. If you want to sort values by a column and reset index, then you can use sort values, and by some column, which I'm using close ascending is equals to true, and reset index, and I want to show first top 5 records. So this is the result. If I want to group by a column, I'm grouping here by name. So you can see true values 1 to 59. If you want to check if the values are null or not null, then you can do so by using isNull function. So you can see there are no null values in any of these columns right now for the top 5 records. Then if you want to show number of records of a column, then you can do this by df.name. I'm showing the count of the name column, which is 19 here. Then if I want to do Boolean indexing, which is basically like I want to show the records which based on some condition like open is greater than 14, close is less than 15, and stock name is equal to AAL, and the columns that I want to show is open, close, and name. I can do so by using this function. You can see the results here. Then apply function. So if you want to see the missing values in each column, so I have created a function here, and then I'm calling this apply function over the column and here over the rows. So x is equals to 0 means column, x is equals to 1 means rows. So you can see there are 11 missing values in the open column and 8 in the high, and likewise in the other columns, and there are no missing values in each row. So for the top record, so it will show you this result. Imputing missing files. So just in case you have a record where the value is null, so in that case if you want to fill that value with something like mean mode, then you can do so by using fill na function here. So from SkyPy I imported mode, then I'm calculating mode for the open column, likewise for the high column and for the low. Then I'm filling the value of all the null in the open column with the mode value, which is basically nothing but the value 70. You can see mode 0 is basically this value, and you can see after running this you can see there are no missing values in the column. And earlier there were these missing values. in each column. This is for the pivot table. You can use the pivot table function, and yeah, you can give a column name here, and by index, open, close, high, and you can do so by mean.